Okay, here we go. We're going to get introduced to variables in Java. So programs frequently need to reference bits of data more than once when executing commands and performing calculations. In Java and other high-level languages, data can be stored, referenced, and modified via named containers called variables. I want you to think of a variable like a box that can store numbers, text, and other forms of data. Right? So we have the variable, the box, and then there's content that we can put into it. In this case, numbers, text, data. Java is statically typed, which essentially means your program must specify the type of data the variable will reference in advance. What do I mean? Well, if we're going to create a box, I'm basically going to say in advance that this box can only store numbers, or this box can only store text. And then from that point on, that's the only type of data that I can put in that. Okay, so once declared, the variable's data type cannot change, and the variable can only reference that type of data. So here is just a quick definition slide. Statically typed means all variables must have a data type, and once declared, only that type of data can be stored in that variable. In Java, we have 8 primitive data types. Right, here is all 8. I only ask that you know these 4 on the left-hand side: int, double, boolean, and char. So here's our syntax. All right, so we kind of got an idea about what a variable is. We want to actually start creating it. Well, in order to create a variable, you need 2 things: a data type and a variable name. And then we have a semicolon here denoting the end of the statement. An example would be int my variable. Right? This int, the data type, well, here are 8 that you could possibly choose from. The 8 primitive data types, those are data types that you could use here when declaring a variable. The variable name is something you come up with. This is what's going to be known as a user-defined symbol. That is, you're going to name the variable something that you can remember, something that makes sense, something that's relevant. In this above segment of code, we're going to declare an integer variable known as my variable. Int is short for integer, which means the variable my variable can be used to store integer numbers or whole numbers. So we're going to create our box. There's nothing in it, but we're going to create our box. We're going to be able to refer to it as my variable. And we're saying in advance that this box can only store integers. And so from this point on, my variable, that's all I can put in it. Once a variable has been declared, what we just talked about was variable declaration, a value can be stored inside of that variable using the assignment operator. So this is 2 lines of code here. We're creating the box, the variable, we're declaring it, and then later on I'm giving it a value. I'm actually taking an integer, a whole number, and using the equal sign, known as the assignment operator, to save that value in. After a variable has been assigned a value, that value is used whenever the variable is referenced. So we declared the variable, we assigned it the value of 7. Here I have an SOP, a print statement, and I am printing my variable. Well, this is not in quotes. It's not literally my variable. It's going to use the value that is currently in my variable. And at this point, that value is 7. As you might suspect, hence the name, the value of a variable can change. If we look at this little bit of code, we're declaring a variable, we're assigning it a value of 7, we're printing my variable. At this point, well, 7, that's what's inside of it. I could then change the value if I wanted to. Here I'm assigning a new value to my variable. Right? I'm changing the value of 23. Now when I print it, it has a value of 23. Let's see this in action. I'm going to hop over to IntelliJ. In IntelliJ, I'm going to make a new project by going to File, New, Project. I'd like you to go through the repetitious practice of kind of creating a project, helping keep these things apart from one another. So I'm going to hop to my AP Computer Science Principles folder. You may likely already be there, in which case that you can just type out variables. So variables is going to be the name of my project. If you did not switch folders, change locations, then IntelliJ likely created that subfolder for you. I, however, am going to ensure that we have a variables subfolder created. This is just good practice. It's going to tell me that variables does not exist. I want to create it. Yeah, let's do that. And this window is just fine. I'm going to expand my project folder, right-click on the SRC, and make a new Java class. This one I'm calling variables. Okay, so we see our class header. We have our class body as denoted by these braces, right? I have an opening brace and a closing brace. Inside of the class body, I'm tabbed over, and I'm going to type out my main method. Try not to copy and paste it. Try to see if you know what it is off the top of your head. Try to type along with me from there. So our main method is public static void main. Open parenthesis, IntelliJ added the closing one. String with a capital S. Java is case sensitive, so that capitalization matters. I have an open bracket. IntelliJ is going to automatically put in the closing one. ARGS. This is our main method header. The sooner you learn it, the better off you are. Public, static, void, main, and string, brackets, args inside of these parentheses. Okay, all this really is this is, whenever we go to execute our program, Java is going to look for this main method. That's how it knows where to start. Just like our class, we're going to have a body using some braces. I'm very particular about my word choice, right? These are parentheses, these are brackets, these are braces. Inside of the body of the main method, this is where we're going to start working. We're going to create our very first variable. In order to create a variable, I need two things. I need a data type and a variable name. We looked at 8 different data types just real fast. I'm going to create an integer variable. So we're going to go int. Notice that this is orange, just like my other public class, public static void. Right? These orange words in IntelliJ, these are reserved words. These are keywords. They have a special meaning in Java. We'll come back to that. But I'm going to create a variable. I have my data type, which is int. I need a variable name, pizza. Right? I go with something funky there like pizza to kind of show it's up to us. In practice, you want something that's relevant. You want something that is specific to your program that makes sense in context. But I just get tired of creating integers like num and num1 and num2. We're going to create an integer pizza, and that with a semicolon. So I have created a box. My box is called pizza. What I'm able to store in it is integers, that is whole numbers, and that's it. On the very next line, I'm going to take that variable, my box, and using the assignment operator, the equal sign, I'm going to put a 7 in it. On the very next line, I want to print off pizza. System.out.println, and in those parentheses, pizza. All right. Notice IntelliJ's happy. I haven't done anything wrong. This is a little bit weird, right? If I were to put this in quotes, we would get the literal word pizza. But instead, I'm referring to pizza, this variable that I created, right? I declared it up here. I gave it a value here. Let's run this program. I'm going to right-click in free space because it's the first time I'm executing and tell it to run. And there it is in our console. At the moment that we printed pizza, it had a value of 7. Okay, well this is a variable, and as the name indicates, it can change over time. And then on the next line, I'm going to take pizza and I'm going to store 13 in it instead. Now when I go to print it off, system.out.println, pizza. Let's see what's in it. Notice we're just going top down, right? I create the box, I put a 7 in it, I print off the box here. At that moment, it has a value of 7 in it. I then change the value that's in it. It's now 13, so when I print it here, we get 13. Okay, so I've had questions in the past about people thinking, well, are both values actually in this variable? No, this thing only stores one integer at a time. Initially, that was 7. And then I changed it to 13. So doing this will replace the 7. The 7's not there anymore. It's now a 13 at this point. Cool. So in Java, this process of declaring a variable and assigning it a value can be condensed into one line or command, right? What we just did is that we declared the box, our variable. We then assigned a value. But this is incredibly commonplace, just to do these things back to back. Create it, put something in it. That can be condensed to what we see over here on the right-hand side. We can declare the variable and give it a value, right? So there's actually two things happening here. It's the whole reason I introduced this concept as two different things is because there's two different things that are happening in this statement. We are declaring on the left-hand side, and we're giving a value kind of on the right-hand side, declaring and initializing. Let's try that. I'm back in IntelliJ. What I'm going to do is create a different integer, mostly just because I can, right? I'm going to create an integer pineapple. Not only am I going to declare it, I'm going to give it a value right away. In this case, 42. Notice IntelliJ is not mad at me. Let's print that off. Okay, I'm going to run this program. We see the 7 and 13. Well, that was from printing off pizza. Then we get down here. We are creating a new variable, an integer, called pineapple, and then immediately storing 42 in it. So whenever I print off pineapple here, we get 42. Something kind of note, pizza still exists at this point, right? And then pineapple gets created, and pineapple also exists at this point. So I actually have multiple variables existing in the same space. We call that scope. More on that later. So, I mean, the order here doesn't necessarily matter. I could come in and print off pizza, which has not changed. It's still 13. If I were to run that, we would actually see that result, right? We see these SOPs. Up here, I printed off 7, and then I printed off 13, and then I printed off pineapple, which has a value of 42, and then pizza, which is still 13, right? That value is still stored in pizza, and pizza still exists at the same time that pineapple does. Additionally, multiple variables with the same data type can be declared simultaneously. Okay, here up top, this is the same thing as what's going on down bottom. Let's look at what's happening down bottom first. I'm creating an integer called x. I am creating an integer called my variable. Maybe I should be saying declaring. I'm declaring an integer called test. These are 3 separate variables, but they all have the same data type of int. We can condense that to just this one line here. Right? This is creating an integer called x, an integer called my variable, an integer called test. Let's try that out. I'm back in my program, and let's create maybe on theme with our pizza toppings. I don't know. We create an integer called chicken and an integer called mushroom. And lastly, spinach. Sorry if I'm making you hungry. These are 3 integers. I have integer chicken, I have integer mushroom, I have integer spinach. I'm able to declare all 3 variables in one line because they share a data type. Notice that none of these actually have values yet. right? At that point, I can come in and give chicken a value of 3. I can give mushroom a value of 17 and spinach a value of 78. If I were to execute this right now and ask, what's printed, or what are we going to see show up in our console, it's still the same thing. It's still going to be 7, 13, 42, and 13. So one thing I'd like you to notice is just because we create a variable and give it a value doesn't mean it's going to show up in the console. The only stuff that shows up in the console is what we print, right? These print statements are what allow that. So we can print things off. Sure, why don't we do that? I'm going to print off chicken. I'm going to print off mushroom. And as we talked about earlier, the order doesn't necessarily matter. I'm going to print off spinach. If I were to run this, we're going to see our pizza print-offs from earlier. We're going to see pineapple. We're going to see pizza. And then we get down to chicken, mushroom, and spinach. Okay, back to our variables. Note that an error will occur if you attempt to use a variable before it has been assigned a value. Okay, let's take a look. Here I'm declaring an integer number. I'm creating a box. Then I try to print the contents of the box. However, there's nothing there. And this is an error. Let's take a look. What if here I got these 3 variables that I'm declaring, and what if we don't give a value to spinach? Notice right away the IntelliJ is very mad. Right? So what's happening here is I'm trying to print off spinach, and spinach doesn't even have a value. If I try to run this, it tells me variable spinach might not have been initialized. Lastly, the result of a calculation can be directly stored into a variable. We did simple math in our last video, right, where we were taking calculations, mathematical expressions involving an arithmetic operator, and just printing them directly inside of an SOP. Well, we can actually take those values and store those into an integer, or into a variable, I should say, right? I'll bring spinach back, but maybe spinach is now 4 plus 92. Okay, so 4 plus 92 gets evaluated, giving me, 96? I then take 96 and using the assignment operator store that in spinach. So whenever I print off spinach here, we see the value 96 show up here. So expressions can be saved there, right? Maybe it's 4 times 92. That's 368. Okay, let's recap. In Java, there are blank primitive data types. 8. True or false? Int variables can be used to store numbers such as 14 and 23.0. That's going to be hard to answer because we didn't really even play with that. We didn't even talk about that. Let's hop back over here, right? We just saw there's 8 primitive data types. Here's my 8 primitive data types. We have int, which is used to store whole numbers, right? Well, what about numbers with a decimal numbers, or numbers with a fractional part? That's where double comes into play. That's the whole point there, right? We're using this to store whole numbers. We're using this to store numbers with a fractional part. Boolean, more on that later. Char, more on that later. Let's create a double variable. Right? I'm going to create a double. Let's go with pepperoni. Let's spell pepperoni correctly. Okay, I'm going to declare pepperoni. Let's go ahead and give it a value. I'm going to give it not just 7, but 7.3. And then I'm going to print off pepperoni. Notice no red squigglies. IntelliJ's happy with what I'm doing, and we see the 7.3 there. Okay, so the purpose of a double variable is to be able to store numbers with a fractional part. Okay, the question that we just saw on the slides is, can we do that with an integer? Well, first of all, let's think about what happens. If I take an integer, which is supposed to store whole numbers, and I try to store that exact same number, 7.3, right away, IntelliJ is very mad. So no, that doesn't work, right? The whole purpose of this data type is to store whole numbers, like 7. But 7.3 drives it crazy. Okay, so the answer to our question int variables can be used to store numbers such as 14 and 23.0. Well, this is a little interesting because 14, that's a whole number. So yeah, integer can do that. 23.0, I don't know. What if, so 7 obviously works, but what about 7.0? I mean, that looks like a whole number. We see that the answer there is, again, no, because it's still trying to hold on to this data, this fractional part. Even though that fractional part is 0, the answer to this question is false. Int, which is short for integer, can store positive and negative whole numbers, non-floating point decimal numbers. Man, I just skimmed past a whole bunch of stuff, right? Let's try this negative number thing that we're talking about. Here I have integer bacon. Well, can I put a negative number in that? -7? Yeah. It turns out -7 is still a whole number, and that works. Our slides also reference the term floating point number, that is decimal. So, in computer science, we try to avoid the word decimal when referring to numbers such as 23.0 or 7.3. These numbers have a fractional part. Okay, we try to avoid the word decimal. I kind of want you to pause and think about why. And the answer is, while we work in the decimal system all the time in the real world, in computer science, we frequently use other number systems, right? Very soon, we're going to be learning binary, right? That's base 2. It's a different number system. And a lot of times, we work in hex or hexadecimal, hex being base 6. Octal gets used sometimes. That's base 8. Hexadecimal, hex, 6, decimal 10. Hexadecimal is base 16. So there's all these different number systems. If you use the word decimal, that implies base 10, or it could be confusing. So when we talk about numbers with a fractional part, we either say numbers with a fractional part or floating point numbers. On a related note, I don't want to dive too much into it, but we saw this primitive data type, float, one that you don't have to know. That's where the name comes from. Float seems like an arbitrary, weird, primitive data type name, but it's dealing with floating point numbers. Don't worry about it. Okay. Java is a statically typed language, which means, that's a small blank to put all this stuff. Statically typed means that all variables have to have a data type, and then once you declare that data type, only that type of data can be stored in it. Right? Java's a statically typed language. We created several variables here. The moment that I create pineapple and say that it's an integer, I can only put ints in it. If I come in and try to put 23.0 into this, that's not going to work. Pineapple can only store integers, that is whole numbers. Something of note, something a little bit interesting. All right, we just tried storing a floating point number into an integer. What about vice versa? What if I took double pepperoni and tried to store not just 7.3 but 7 in it? Notice right away IntelliJ is not mad, but something interesting happens here. Let's print this off. Let's print off pepperoni and notice that 7.0 is what's actually in the box. I took 7, which is an integer, it's a whole number, and then I saved it into pepperoni. Once it's in pepperoni, it will be treated as a double. Yeah, kind of an interesting thing. In Java, the equal sign is known as the blank operator. Assignment. The following lines of code can be condensed to. Pause. See if you can answer this. Very specific. Right? We have variable declaration, and then we're actually assigning a value. Well, those things happen incredibly frequently. In fact, we'll kind of migrate away from this and do a lot more of this, but we are declaring and initializing, that is assigning, our variable. True or false? The following segment of code will produce an error. Our answer here is true, and I want you to think about why. Right? I'm declaring the variable, and then I'm trying to use it. I'm just printing, but I'm trying to use it, and it doesn't have a value. I'm saying, hey, what's in the box? And there's nothing in the box. That's it for this one. I'll see you in the next one.